So in this video, we are going to not only talk about what's going to be on the memory quiz, but we're also going to do a few of the homework problems together. Okay, so we'll do a little bit of both. The memory quiz will look almost identical to what you see here. Let's go over the three Pythagoreans that you have to know. The Pythagorean theorems we know as a squared plus b squared equals c squared. And it all comes from the right triangles that we can build within the unit circle. The first one you want to build or write down is that sine squared of theta plus cosine squared of theta is equal to 1. Now, if you forget the other two, technically, the other two can be built by the first one. If we divide everything through by sine squared, so you can do that mentally, or you could do that on the back of your paper. If you did that, you would get 1 plus the cotangent squared equals the cosecant squared. And then if we did the same thing, but instead of dividing by sine squared, if we divided everything through by cosine squared, we would get our final Pythagorean, which was that tangent squared plus 1 equals secant squared. So no matter how you end up finding them, whether you just memorize all three, or if you memorize sine squared plus cosine squared equals 1 and you derive the other two, those are the three Pythagoreans you have to have memorized. Now, on the quiz, I am going to give you the opportunity to get yourself some bonus. The bonus you could get is if you can rearrange them and come up with the alternatives to any of those on the back, you can also get some bonus points. So here's what I mean. This first one here, if I subtract the cosine squared to the other side, one alternative to our first one is that sine squared is 1 minus cosine squared. So if you put that on the back of the quiz, I'll get you some bonus. Another alternative to that is, what if you leave the cosine squared, but you subtract the sine squared to the other side? So you could also say that cosine squared equals 1 minus sine squared. Now, there are two variations of this one, two variations of this one, two variations of that one. Now, I'm not going to write them all down because that would be your chance to get yourself some bonus if you put some of those variations on the back. Okay, so those are the Pythagorean. Now, let's go to the even or odd. For your even and odd, the main thing to remember is that these two are odd, and this one is the only one that is even. If you tell me odds or evens on those ones, I'll tell you, or correctly, I'll give you some points for that. This one means because it's odd, the negative can come out in front. And this one is odd, so the negative can come out in front. The only one that doesn't do that is the cosine. Because it is even, the negative does nothing to change the original function. So that is the even and odd identities. Okay. Now let's go and work on our reciprocal identities. The reciprocal of the sine is the cosecant, so that's 1 over the cosecant. The reciprocal of the cosine is the secant, so that's 1 over the secant. And the reciprocal of the tangent is the cotangent, so that's 1 over the cotangent. In this section, the way that you can get yourself bonus is by writing two different alternatives for those. So let's talk about the alternative for the first one. One thing you can do is you can just cross multiply by cosecant. So if you write that the sine times the cosecant is equal to 1, that is a variation you can write and get yourself a bonus point. Another variation is to just switch places between the sine and the cosecant. So you could also tell me that the cosecant is 1 over the sine. So each one of those has two variations that you could get to get yourself some bonus points. Okay, so the first three Pythagoreans have two variations. The even and odd, you could just tell me if they're even or odd. The reciprocal, each one of those has two variations that you could tell me on the back of the paper. Okay, and then our last one are our quotient. Our quotient identities is just that tangent is sine over cosine, and cotangent is cosine over sine. There are actually some variations there. So tangent is sine over cosine, cotangent is cosine over sine. There are some variations there to get yourself some bonus. I'm only going to do the first one, and then it's up to you to kind of think about how you could do the same thing to the last one. If we were to cross multiply by cosine, I know that the tangent times the cosine is equal to a sine. So that's one possibility. Or we can flip-flop the location of our tangent and our cosine. I know that the cosine is the sine divided by the tangent. Now, the reason we have those variations is sometimes the exact thing isn't in your problem, in your identity, but a variation could be, and you can use those variations for your substitution. So any of those variations, you can get yourself some bonus points on the quiz. So your memory quiz looks like that. Please make sure that you, at this time, take a picture of what you've just done. Turn it into the, where on Google Classroom it says memory quiz practice. Just take a screenshot of it, put it in there to get yourself some points. The quiz will be Monday and it will look like this. Okay. Any questions before we talk about some of the homework? So the homework coming up that's due is 9-1A and 9-1B. So at this time, I had done a few of the 9-1A homeworks for you. At this time, maybe even some of the 9-1B, I'm not sure, but could you please open up your 9-1A and B homeworks? And I'm going to open up mine too. So the 9-1A homeworks, we did a few of those. Here is our 9-1B homework. There's only 4 of them because, you know, these are time consuming. What I would like to do is I would like to do number 2 and number 4, and it is your job to finish up the rest, okay? So everybody open up your 9-1B homework at this time. Now remember, the idea of a trig identity is to use all of your facts that we just wrote down for the memory quiz, any variation of the facts, to allow us to simplify one side and only touch one side until we get it to match the other, okay? So what I notice here is this side to me seems much, much simpler than this side. So this is going to be my hold. I'm going to hold that side. I need to keep in mind that that's really 1 over the cosine. That's my hint as to what maybe the second to the last step will be on the right. But I'm going to hold that side, and I'm going to mess with the right side. Now, one of the hints I had told you when we were taking notes was if you see lots of trig functions, your goal should be to rewrite everything with our identities in terms of sines and cosines, okay? So that sign that's sitting in front of that parenthesis, well, it's already a sine. But because of the quotient identities, I know that tangent is sine over cosine, and cotangent is cosine over sine. So you can see that our sines and cosines are living in there. Now, one thing to note, this is one thing, secant, which is one fraction, 1 over cosine. So I have to find a way to merge those things together. Well, to merge these things together, to add fractions, you have to have a common denominator. So we're going to do a little trick now. And the trick is we are going to multiply this fraction by the denominator on the right, so by a sign, and we're going to multiply this fraction by a cosine. Okay. Now, when we do that, watch what happens. We can now add the fraction and have one denominator. So our goal is to put these things together. On the left side, remember the left side is our answer. It's like, hey, I told you the answer was 2. Get there. Well, I told you the answer was secant. That's one individual little piece. So we got to mush all this junk together. To add fractions, you get a common denominator. Your new fraction will be that denominator. And your numerator, you just add the junk together. So sine times sine is sine squared. Cosine times cosine is cosine squared. Does anybody see what has just appeared in the problem? What has just appeared in the problem that we didn't see before? So you got it, the squares. Those squares are from our Pythagorean. What is sine squared plus cosine squared equivalent to? 1. So what's great, what just happened is we got something much, much simpler. There's no pluses or minuses anymore. We got 1 over the cosine times the sine. Now, look how close we are. Now, just like, remember back in geometry class, you did proofs. And in a proof, you had to show every step and kind of make a justification as to what rule you used. In this type of identity, in a way, it is a proof. I'm proving the one side matches the other side. The proof is in the pudding is a silly saying, but basically you got to show me all the steps. So this next step, show me that I can multiply through, and since the sign is like a whole thing, it's going to go on top. Show me how that multiplication then cancels out the sign. We were searching for a 1 over a cosine. We found it. Oh my gosh, what is it? That's a secant. So now we write it on the both sides, and we put a little arrow notation, meaning, hey, we just got it to match. So that is number 2 from the 9-1B homework, okay? Are there any questions as to how we did that? So some common threads, let me remind you. If you have lots of trig functions, make them sines and cosines. If you have fractions that are added, you usually are going to get common denominators and combine those fractions. That's a very common step. If you see squares, think Pythagorean. There might be a Pythagorean there. And then you just got to do algebra. Usually it's a substitution algebra. Substitution, do some algebra. Substitution, do some algebra. So that is number 2. Do we have any questions on number 2? Okay, let's now go to number 4. Number 4 I saw as a pretty difficult one. And I saw it just because it's fraction on one side, not fraction on another. So I like to try to help you there. I see on top here, I notice that there's squares. We have, so by the way, I'm going to hold this side. That's my answer. My answer is 1 over cosine squared, or secant squared, okay? So just keep in mind, I want to get 1 over cosine squared so I can make it a secant squared, okay? If we look at the Pythagorean that has a cosecant and a cotangent in it, normally we write that as 1 plus the cotangent squared equals the cosecant squared. That's the second one that I wrote down on the memory quiz. What do we have to do to this to get it to match that? How do we have to rearrange it? What do we got to do to this to make it match? What do we got to do? We have to move something, right? Don't we have to move this by subtraction over here to make that a match, what we see there? So think about if I subtract a cosecant, I get, or I'm sorry, a cotangent, I get that 1 is equivalent to a cosecant squared minus a cotangent squared. So this top is equal to 1. I am allowed to do a substitution there. Let's look at our bottom. The Pythagorean identity that contains a sine is sine squared plus cosine squared is equivalent to 1. How could I rearrange that one to get it to match right there? How could I get that one to match there? So it's a sine. Subtract the sine. So if we subtract the sine over, watch what we get. We get cosine squared is 1 minus sine squared. So that is a perfect substitution. I can replace this with a cosine squared. So this one actually became easier than I expected. Because what is 1 over a cosine? By our reciprocal identities, 1 over the cosine is the same as a secant. So 1 over cosine squared is the same as a secant squared. So you only got 2 more to go, but you do have 9-1A, 9-1B, and you do have an ALEKS that is due. So for the remainder of class, please work on finishing up some of these.